Dr. Leif Busk, who is the chief scientist of the National Food Administration. We also known each other for many years, and I know you trained at both Karolinska and Uppsala University, and you worked at the National Food Administration for a long period. Leif, the floor is yours. I look really forward to how Livsmedelsverket, the National Food Agency now, you were administration previously, looks on additives and enzymes in food. Thank you.
Thank you for that nice introduction. And thanks to the organizers for inviting me to come here to speak today. I will try to give an overview of what we do with additives at the NFA. And you'll see that much of what I say today has been touched on yesterday and this morning by Hubert also. This is the synopsis of my speak. A short introduction to the NFA and the principles of risk analysis. I'll start with that in a few slides. And then I'll talk about some general Swedish policies, both when it comes to risk assessment and risk management. And I have some examples. We have had special interests from the Swedish point of view. Nitrate, artificial sweeteners, hazy dyes, that's history telling, and something about emulsifiers where we have some concerns that we think needs further research to elucidate. And then I'll turn into communication. We'll touch upon things that we've heard yesterday by Leif through here. From a national experience, communicating risks. And that'll turn over to something that I really am burning for, so to say, today, and that's risk ranking. And what risk ranking can do for you when you want to compare the risks and put things in perspective. And I'll talk about the Swedish risk thermometer, which is a new invention that we made at the NFA. This is the headquarters in Uppsala, where we have a staff of 550 at the agency in total, 330 at the headquarters, and 220 out in the local offices, slaughterhouses and border controls. And the budget, about 500 million Swedish kroners. Less than half of that is from the state budget, the rest is fees and research grants. We have three main tasks at the NFA. Safe food, work for safe food, work for fair practice in the food trade, and try to develop healthy eating habits in the population. And in more detail, we are supposed to develop and perform laboratory analysis, chemistry, microbiology. We have about 80 people working in the labs in Uppsala. And we're supposed to conduct investigations on the composition of foods and the dietary habits of Swedes, and to make risk and benefit assessments. And that is what we do in the department where I am employed, the Department of Risk and Benefit Assessment. We also work developing legislation, and as you know, this is a harmonized area, so 95% of all the regulation is done together with the other member states in Brussels. But only a minor part is national nowadays. We do food control, we look at big factories, food producers in Sweden, and we support the local control also. And we issue dietary advice to consumers based on the science that, among others, EFSA produce. And we communicate with consumers and with industry. And the important thing here is also that the work, everything we do, shall be guided by the principles of risk analysis, and that is stated in the food law. So what is the principle of risk analysis? Now, I suppose you've seen this slide before, but I will show it anyway. The separation of risk assessment and risk management. Usually risk communication is the third circle that sort of touches the two other ones, but I prefer to do it like this. Risk assessment and risk management embedded into risk communication. And this is the science part is the risk assessment, and the policy part is the management. And this system was laid down by WHO, FAO in the 1980s. But we have, in both assessment and management, we have policies, risk assessment and risk management policies. And these are value-based to a very large extent. Now, we think about, of course, management as policy-based and value-based, but there are surprisingly much in the pure, so to say, pure scientific part also that really is value-based. And I think it's important that we point this out when we do scientific assessments. I'm trying to convince my younger colleagues at the NFA that this is the fact. But just to give you one example, the size of safety factors, for example. There is some science to support the safety factor of 100. Well, I mean, in the beginning it was pick in the air. And to some extent it still is, that is value-based. I could talk for this for a very long time. This interests me very much, but I will leave you with this. And in order to live by the principles of risk analysis, we have this organizational chart. We have the science division, the biology, chemistry, we do the laboratory analysis, the risk and benefit assessment, where I work. And then we have a slight anomaly here, I would say, because we have the advice and emergency preparedness, which is risk management in the science department also. But we handle this quite good, I think, about chain of commands and how money flows. So there's a reasonable amount of independence. Then we have the food control division and the strategic development support decision, where, as you see, international affairs, that is the negotiations in Brussels, in the legislative work. So then to some policies we have. When it comes to resource allocation to scientific work with food additives, there's a long history of this. The NFA was started in the 70s, and food additives were a top priority in the 70s. And we banned the use of dyes, and this had a huge optical effect in Sweden. Now there was a new agency here who took responsibility for the safety of foods for Swedes. That was very important. And we set up a registry of additives, which is quite cumbersome. It's a computer size of half of this room, with the computing power equivalent to a mobile phone today, where we try to keep track of all the additives in Sweden and what foods they were present and the levels. Huge amount of work. 10 people at least worked with this full time. This was phased out in the 80s because it was too cumbersome. And then we had financial constraints, as many other authorities. In 2002, we decided that we should cut down the national work on food additives, and concentrate on the support to EFSA. And you see the two guys who work with this now. So we moved from roughly 10 people here down to these two, and they are allowed to use 0.3, 0.4 person year, a good year on additives. That is the amount of work that we put in science today, and it goes mainly through EFSA. When it comes to how we deal with EFSA, then, well, we have the hazard characterization that Hubert talked about, and I say we have no major divergent opinions compared with the panels. We go in and do some things. For example, Allura Red. I'm hitting the wrong button here. Allura Red, where there were conflicting opinions between some EFSA panels based on actually lack of knowledge or lack of data, and we went in there and did some experimental studies on genotoxicity to help EFSA to clarify the issue. But what we would like to see is a further development of the assessment procedures for cumulative exposure, and this is on the way. We are working quite intense on that in the pesticides area, but we need to transfer this to other areas also, and I'll come back to this a little bit later. And we would like to see more evaluations of environmental risks. And this is not really up to EFSA to decide to do. This has to do with the legislation and what we ask of EFSA in the legislation. And there's an anomaly here because there's actually more demands in the legislation for feed additives on assessing environmental risks than there is for legislation for food additives. And then the exposure assessment. Well, EFSA bases its assessment, as pointed out by Hubert, on the PAN, European Food Consumption Pattern, together with sponsor estimation of exposure. And what we do regularly, and that is much of the work that Nils Gunnar Rydbeck is doing, is to look at sensitive groups from a national perspective. That could be children, it could be diabetics, or other groups that have some kind of abnormal consumption patterns. If we then move to the management part, what policies do we see there? Well, we of course we work according to what is said in the food law. Safety assessment made by EFSA. There should be a technological need. Ensure that the use will not mislead the consumers. We had something that we phrased like this earlier on. We demanded to see some advantage for the consumer. But that, I would say, today is that a secondary criteria. And that is mainly because it's difficult to define what this is. Consumers are different, and what is an advantage for one consumer, another consumer saying, oh, that's not any advantage to me. I think Lynn touched upon that yesterday also. So this is a secondary criteria today. Now I come to the history part. We've done a lot of work on nitrate, and we've heard a lot about this yesterday, so I will not go into any details here, just to point to some things that we see problematic with nitrate. We talked about the nitrosamines, the carcinogenic granules yesterday. The problem is that if we look at nitrate as such, and nitrization endogenous in the stomach of humans, it is problematic to know if we have really formation of the known animal carcinogens in man. We have them in the food, and we did substantial work on the formation and occurrence of these in food starting from the 1980s. So we have a tradition on the focusing on nitrosamines as a problematic contaminant in foods in Sweden. But there is difficulties in quantifying the risk. And we've seen estimates less than 1 cancer case per year up to 100 cancer cases per year in Sweden. I tend to believe more in this figure. I don't think that nitrosamines in food is a major problem in Sweden. Others might think otherwise. Nitrate, also pointed out yesterday, might be a bigger problem. Simply because 5, perhaps up to 20% of the ingested nitrate is converted to nitrate. And looking at the exposure of nitrate and nitrate, I have data here from the UK, but the situation is the same in Sweden. If we look at what is the dietary nitrate intake in UK, it's difficult to say here, but oh, it's 91 milligram per person a day, it says there, 91 milligram. And if you go to nitrate, it's 1.5 milligram. But if you add the conversion of nitrate to nitrate, you end up with 7.3 milligram. That means you get 5 times as much what is present in the body as nitrate from nitrate. So nitrate might be more important than nitrate if you think that nitrosamines, for example, is a problem. We've been interested in artificial sweeteners also, cyclamate for example. And we did some work on the pharmacokinetics of cyclamate as one example, where we found that the formation of cyclohexamine differed between rats and man. And the rats were the standard for the setting of the ADI. And this resulted in a lowering of the ADI with 50%. We did a lot of work on the intake of cyclamate, also in diabetic children, for example, that was shown to have too high exposure due to the intake of tabletop sweeteners. So new dietary advice were issued to these groups. We've done a lot of work on aspartame also, mostly in the EFSA working group of national experts. We supported the UK study on volunteers, people who claim to have problems after eating food containing aspartame. They were recruited into a study where they were exposed to chocolate bars, I think it was, with or without aspartame, and the alleged negative health effects could not be substantiated in that study. Azodize, of course. Azodize that we prohibited when we were a very young agency in the 70s. We estimated that about 3,000 to 4,000 people were sensitive with skin reactions. And when we joined the EU in 1995, we couldn't get an exemption to keep the ban, simply because we couldn't show that it was allergenic, these compounds. We couldn't show either that the Swedes were more sensitive than others. Well, we didn't try. To be honest, we didn't even try to show this. I made a calculation on the type of study that you had to do to show this, if the effect was there. And when the authorities, the government saw the price tag on that study, they decided, well, perhaps it's a better idea to let this go. But it initiated a media debate. Are we now entering the EU? Does the food safety become less a focus? Do we have to accept food that is not safe? And that debate, we still live with parts of that debate, I would say. So we have done some studies to look at the exposure of azodize, for example in 2006, where we had 3 different things we did. We looked at labeling, we had a questionnaire to the food producers, and we did an in-house project on the analysis of sweets and drinks on the market. And the results of this is shown here, where indeed you could see that there were more azodize on the market compared to a study in 1991 where only 1 product contained azodize. We found a number of azodize in the 2006 study. So there's an increase there since 1999 anyway. Swedish producers, food producers, they have a general policy of restriction when it comes to azodize. Only 7 of 58 producers of confectionery, drinks, ice cream and fish products use the dye. So there is less azodize in Swedish produced foods. We did the analysis on candies. 11% of the sweets contain azodize, compared with 15% in the early 2000s. So there's no increase there either. We didn't find any azodize in soft drinks. And this, of course, helps in the communication about was it a good or bad idea to join the EU and adopt the rules that we have in common within the common market. This is something new. We have an interest in emulsifiers, and that is due to research that we've done at the Risk and Benefit Assessment PhD study here, thesis here in 2012, looked at the absorption of toxicant in the presence of dietary fatty acids. And you can see that DEHA, for example, and oleic acid increase the uptake of, in this case, aluminium and cadmium in different systems. Cockatoo cells are cells that come from the colon. Cancer in the colon is an established cell line to look for effects on uptake of chemicals. And the hypothesis here, and we are not alone about thinking about this, is that surface active compounds, such as fatty acids or emulsifiers, they can impair the intestinal epithelium in such a way that you get an increased absorption of molecules that perhaps might be allergic or autoimmunogenic. And this has been brought up to what Hubert talked about earlier on, the M-risk platform at EFSA, where we look at emerging risks from a European perspective. And the data has been weighed there and said, yes, this might be a problem, so this has been submitted to the ANS panel for further considerations. And I don't think that much has happened since, because there is a lack of data here, there's a need for more research. But this is something that we believe is important, because you can see from many epidemiological studies that there is an increase in these types of illnesses, and this could be one contributing factor. Other general trends that we see in the food additives area. 5 minutes left. Fine. 4. Good. Clean label. Fighting food waste. If we look here, the sensitive area in immediate terms. Consumer demands products with less additives. Most producers try to accommodate this. And what we do, and the authorities, are to focus on possible new problems. And we have, I'm not saying that these things are problems, but of course, when you replace additives with natural components, are they just as safe as the additive? This is something that we would like to know from a agency perspective. Are the minor ingredients, are they additives? For example, here citric acid prolongs shelf life. Potatoes. Different views on the appropriateness of this also. But I would like to talk now a little bit about media and alarms. And when we have these media alarms, additives is a part of that, of course. You see that here on this list here on the left-hand side. And Lynn said that yesterday that it would be a good idea if we could be better at separating hazards and risks when we communicate. And here is, in my view, a good illustration of this. You have a wave. We're standing on the beach. Is that a risk? No, it's a hazard. No exposure. But if you take your wakeboard and go out, as on the right-hand side, you expose yourself to the hazard. Of course, there is a risk. And much of the debate, I would say, earlier on anyway, when we talk about additives, is talk about the inherent properties of the additive in high doses, as Hubert also said today, to cause damage. But standing on the beach, that is having a low exposure as you have in food, there is no risk, it's only a hazard. So it's vital to rank risks in communication with consumers to increase the public trust in authorities. And this, I have now a few slides. The risk thermometer is a way of doing this. And what we do here, and the math is quite complicated, but what it is that we have done a severity adjustment of a measure that EFSA uses every day in their assessments that are called margin of exposure. I will not go into details about this, but we add severity of the effect because severity is we have a model for uncertainty, a risk classification approach, and a graphical illustration of this. I'll tell you what this is. This is just to illustrate that as you increase the dose of a substance, you get more and more severe effects. And we have classified these different severities and give them numbers and put them into the programming here to adjust the margin of exposure, which is the normal way of looking at risks. And here we have two examples. This is the way it looks. This is the way it is presented to the risk managers. 17 organophosphates for children. You see we have 5 risk classes and the 7 organophosphates, insecticides, for children, average consumers, are in class 2, no to low risk. This is the uncertainty. Lead from foods, adults, risk class 4, moderate to high. And it's not risk, it is concerns. But our Director General wanted a risk thermometer, so he got a risk thermometer. But it's really a concern thermometer, to be honest. But this illustrates that you can do it on groups of compounds, single compounds, you can do it for children, you can do it for adults. And this is the last slide that I have, and I got this at 10 o'clock last night from my co-worker who was working with this. We did a survey on, looked at neotame. And you can see we have 4 different exposure scenarios. Adults mean exposure, adult 90 percentile, children medium, children heavy consumers. And in all cases, this is extremely low risk or concern. It's only for children, heavy consumers, where you pass over to risk class 2 or concern class 2. But this is the way that we communicate risks now to our risk managers, and they find it useful, I would say, because they can see that, well, you say that this is no problem, this is no concern, but the uncertainty goes over to risk class 2, and that could mean that perhaps we should look a little bit more into this. So this is the way that we do things now, and possible future developments, the absolutely last slide. We talked about regulation of pesticides. There we have introduction of cumulative assessment groups, and if that will be the case in food additives, and I hope it will be, then there is a need for better precision exposure assessment, a better alignment between the food categories and the regulation of additives and the system that EFSA uses now for doing food consumption studies, the Food X2 system. And we need more detailed information on the occurrence of additives. We'll never have the system back with the database on occurrence of additives that we had in the 70s. But I think we can do better actually to keep track of where we have the additives and what foods. And this causes problem not to know this. I'm just pointing at this Southampton study where 6 ACE dyes were used and to provoke hyperactivity in children. But is there any child that is exposed to those 6? We can't tell because we don't know. The Irish think that they know that there's not a chance in the world that this would happen because they keep a better record of the occurrence of food additives than we do. And I would say that not many member states have a reasonably good system for keeping track of additives occurrence data, and I hope that we can have that in the future. Thank you for your patience.
Thank you, Leif. Are there any questions directly to Leif?
I was struck by the name of your department, the Risk and Benefit Assessment. I think that's a great thing to do. Do you do both for the same compounds as well?
Yep.
Do you do risk versus benefit as a rule instead of as an exception?
We try to do it as a rule, but the risk goes with the chemicals and the benefit goes with the food that the chemical is present in. So there's very seldom a trade-off on a one-to-one with the chemical, but it's the food that contains the contaminant that stands for the benefit. So, and this has an impact then on how you give dietary advice.
Okay, thank you, Leif.